What if the most dangerous hacker in the world wasn't a person sitting in a dark room, but another AI? That's essentially what this paper is about, and the results are pretty alarming. Modern AI systems have censorship built in. You ask a model how to make something dangerous, it refuses. These guardrails are strong, but they can be broken, and this is called jailbreaking. The researchers took a specific class of LLMs, called large reasoning models, which are designed to think through problems step by step before responding. Think of them like an AI that makes a plan before it acts. And they gave these models one instruction: jailbreak another AI. Here's how the attack works. The reasoning model is given a harmful goal, say extracting some instructions for something clearly illegal. But it never says that directly. Instead, it starts a conversation with the target AI completely normally. It builds confidence by asking some general questions, and then it slowly steers the conversation using certain techniques. 1. Framing the request as something educational. 2. Wrapping it in a fully fictional scenario. Or 3. Varying it in dense technical language. The attacker model doesn't see the whole plan. It only sees one message at a time. And by the time it's producing harmful content, it got there gradually, almost naturally. It reminds me of the story about boiling the frog. And the coolest part is that the attacker model does all of this on its own. No human input after the initial setup. And the results say that across 4 different attacking models and 9 target models, the jailbreak succeeded in over 97% of cases. Some of the most widely used models in the world, including models from OpenAI and Google, were successfully compromised. The one standout exception was Claude Sonnet 4, which proved significantly more resistant than the others, refusing harmful outputs in the majority of cases. The researchers also tested whether the reasoning part was actually doing the work, or whether any AI could pull this off. When they swapped in a standard non-reasoning model as the attacker, using the exact same setup, the success rate collapsed. So yes, it's specifically the planning and strategic thinking of these newer models that makes the attack possible. This paper shows something interesting. As AI models get smarter, they don't just become better at the tasks we want them to do, they also become better at the tasks we don't. The researchers call this alignment regression. More capable models may actually make the whole system less safe because they can be turned against it. One mitigation that the paper tested, appending a safety reminder to every incoming message in the target model, did reduce the attack's effectiveness significantly. But it's not a complete solution, and it may come at the cost of making the model less useful in general. We're at a moment where the tools we build to make AI safer can themselves be repurposed as weapons. Understanding how these attacks work and publishing that understanding is how the field starts to build this new form of defense.